Welcome to the walkthrough of the frequently made mistakes for the assignment 2B submissions. First and foremost, please make sure to document all of your code. It's not enough to write the solution correctly. You also have to explain why you did it the way you did. In addition, please make sure to fix all my comments on your assignment 2A submission before you submit your final version of assignment 2B. Quite a number of people didn't do that for the preview submission, and so as a result, I wasn't able to provide you with comments. Something else I should also mention, please make sure that you always run the unit tests before you do your submissions. They catch many problems that we're about to look at here, and by running them, you'll have a leg up on trying to figure out what you've done wrong and how to fix it before we actually do the final grading. Let's now start taking a look at some of the problems with the actual implementations themselves. Here's an example from the assignment 2A submissions that people didn't quite get right with their revisions. This is in begin being thread pool. Please note you don't need to initialize the futures via an array list and also use collect in the stream below. I recommend just using the stream with collect, so in other words, get rid of this one. But make sure you understand why that's the case. Make sure you understand why using this solution here is better than trying to use the allocation of the new array list. It's much less error prone. Here's another problem I saw a lot of people make. If you write Java 8 streams code, please don't cram all of your streams code into a single line. Instead, break it up more like this, where you can have comments occurring before each of the various aggregate operations. And also, this particular example has too much complexity with the collector. Just use toList rather than using toCollection and the array list new constructor reference. If we take a look down here, here's an example where the code is more complicated than necessary. Please replace this type of code with a method reference. It's much cleaner and easier to understand than trying to read this code. Let's take a look at some other problems that were left over from assignment 2A. This is the await completion of futures method. Make sure you don't use a thread. You don't need to use a thread in the solution of await completion of futures. And also, please make sure that you use the new skeletons. Some people were using the old skeletons, which have incorrect comments or things that are out of date. So make sure you address and use the newest skeletons. Also, please make sure that you keep track of which futures completed successfully and log it. And also, of course, log it if it's gone wrong so you can see what's happening. Here's another example of something that can be improved in await completion of futures. You don't need to call get twice. Just call it once and store it in a local value and then use it below. Here's yet another example of await completion of futures that can be improved. You don't need to actually call collect here. There's no need to collect things into a list. All you need to do here is simply use a lightweight terminal operation, such as count, for example. Here's yet another problem that I saw a lot in await completion of futures. Please make sure you keep track of what's failed and make sure that you also indicate what's going wrong here in the case of where it fails or where it's successful. This is yet another case where you should be logging that information properly. Here's an implementation of await completion of futures that just doesn't make any sense at all. There's no need to go into a loop checking while the future is done. That's what get is for. Get, as you should know by now, will block the calling thread until the future is finished, until the computation is completed that the future relates to. And also, I don't understand what the mthread.wait is doing. That just makes no sense at all. That will most likely just block indefinitely. I don't know how it's going to ever get released. Coming down here, here's another begin being thread pool problem. This particular piece of code is going to blow up if the get being count is less than or equal to 0, because of course we're not going to initialize the executor service field. So that'll cause you some problems. So you have to make sure that you don't do that. Now we're moving into assignment 2B. Lots of common problems with the simple semaphore. Something important is missing in this piece of code. please make sure you go back and read the comment which said you have to make sure you put a type qualifier here that will ensure that the value is not cached in a thread cache, but instead will be flushed back to main memory. So there's a particular type qualifier we've talked about that will do this. Likewise, do not use static here. That's the wrong type qualifier. Static will do horrible things in this case because you'll only end up with a single instance of M permits no matter how many simple semaphore objects you have, which is absolutely not what you want to be doing in this case. Here's a case where we don't need to use something as heavy as atomic integer. Instead, use something lightweight like int. Another minor point, but it's important to understand why you need to do this. I recommend using lock here, which is an interface, rather than reentrant lock, which is a class. It's always better to try to use the interface whenever possible. And also, the comment that I don't have here, but was there in your code, says use a condition. And so don't use a Boolean called no permits available. That makes no sense whatsoever, is not thread safe, and is incredibly inefficient and just doesn't work. So don't do that. Here was another common problem I saw. People were creating local fields, setting them to null, and then trying to use them in the initializer portion of the fields of the class. Don't do that. Those things belong in the constructor. For some reason, people were doing some odd things in the simple semaphore constructor. They were not using the permits parameter, or they were not initializing the condition object, and so on. So you got to make sure that you initialize all the fields properly. Otherwise, bad things will happen. Here is some other problems that I saw with acquire uninterruptibly. A lot of problems in this method. So first of all, you need to use a condition object rather than using a Boolean. So that's one problem. Please also just get in the habit of saying m permits minus minus rather than something like m permits minus equal 1. And then when you're dealing with the uninterruptible case, you need to do these re-interrupt calls outside of the try finally block, and that's to ensure that the flags are not reset by other calls that may occur later, like unlock, for example. So the best way to do that is to have a Boolean flag that you can set, and then check that flag right before you exit and do the appropriate operation to reset the interrupt flag, or to indicate an interrupt has occurred. There's a bunch of interesting problems here. These are real subtle issues. If you take a look at the await uninterruptibly method, it doesn't really clarify what it does with the interrupt status flag. So it's probably not the best thing to use it. It may work in some implementations, but doesn't appear to be guaranteed because it's not documented. Also, make sure that you don't decrement m permits every time through the loop. That will cause all kinds of problems. You'll get the wrong count. And you don't need to put a signal in the acquire or acquire uninterruptibly method. That really only belongs in the release method to wake up anybody who's waiting to acquire the lock. You don't need to call signal here. There's no reason to do that. This particular implementation also is not handling the interrupted exception properly. It's simply swallowing it, which is not what it's supposed to be doing. Moreover, as in this example, the interrupted exception is not an error. It's meant to be an interrupt, and you need to track the fact that it occurred and then use the fact that it occurred to do something at the end right before you exit the acquire uninterruptibly method. Here's the acquire method. It's somewhat different than acquire uninterruptibly, and the main idea, of course, is that you can interrupt it, and it throws interrupted exception. Wasn't clear really why unlock is being called in two places. That's why we have a finally block. So get in the habit of using the finally block, as we've discussed in class many times in the various lectures. And you also don't need to be throwing the interrupted exception. If you use the finally block properly, then that exception will simply be propagated out of that method, which is exactly what you want. Here are some real serious problems in this code. So first of all, you can see that permits is being checked without the lock being held, which means that all kinds of chaos and insanity will happen. You've got a big race condition. This decrement is incorrect. Don't be calling lock interruptibly inside the loop. That makes no sense at all. That will be, I'm not even sure how on earth that would have passed the unit test. So make sure you run the unit test to find these kinds of problems. This code also is calling itself recursively somehow, and it looks to me like it might infinitely recurse depending on various things, so that's obviously a bad thing. And this particular code is not actually unlocking the lock. The lock was not locked properly, but it's also not being unlocked correctly either. Another thing I saw a few people do when you start implementing the release method on the simple semaphore, never call signal all in this context, just call signal. And moreover, don't call signal in the finally block, but put it in the try portion of the try finally. There's another problem in release here. This again has a huge race condition because permits is being accessed without the lock being held. There's no reason the lock is held at this point, so you need to make sure that you acquire the lock. And then in this case, we're unlocking a lock that's not locked. And also notice that if you call signal, you can do a special check to make sure some properties are true with respect to the current value of permits. And you only want to call signal if permits has a certain value or a certain range of values. So make sure that you optimize the call to signal. There's no reason to call signal if there's nobody who's waiting. Here's a simple minor problem. Just make sure you use mpermits ++ rather than mpermits plus equal 1 or mpermits equal to mpermits +1. These are just good techniques to get in the habit of doing with Java code. Don't put the signal call in the finally block. That could cause problems. And again, kind of alluding to what we talked about before, this code here can be optimized. So you can do a check related to permits and the permit count and only call signal under certain circumstances. Some more problems in release. This code is not calling something that's very important. In fact, it's one of the most important things in release. You need to find some way to inform any waiters that the semaphore may be available now. So if something is missing, make sure you fix that. That should also have been caught by the unit test, so make sure you're running the unit tests. Here was a strange implementation of the getSemaphore accessor method, or so-called getter method. This should just be returning the semaphore, which in this case was called mAvailablePalantiri. So make sure you allocate mAvailablePalantiri in the constructor and simply return it here rather than allocating it in getSemaphore. And the reason, if you were to take a look at the rest of the code, getSemaphore is called multiple times, so this of course will be creating a new semaphore each time, which is wildly wrong. Here's one of the few problems I saw with build model. Make sure that you initialize the semaphore with the appropriate count, not the count of 1. The count, of course, should be equal to the number of the palantiri that you're going to be using. Here we are in the acquire method. Now we're looking into the manager, the palantiri manager class. You don't need to have a try catch for this case, especially if you're just going to ignore it. Just go ahead and make this acquire be used elsewhere in a broader try block. For some reason, after checking, first calling acquire on mAvailablePalantiri, now the code is checking to see if mAvailablePalantiri is null. Well, that's probably unnecessary in the first place, but in any case, don't check for null after you've already tried to use the pointer or the reference. That'll cause all kinds of problems. Here is another problem I saw a lot of people make. Make sure that you don't assume that the first entry, which we see here is using a stream to find the first entry that's actually available. Don't assume that it's there. So don't ever have an optional and then just call a naked get on it. That will cause you all kinds of problems. So don't do that. You need to do some other things if you're going to use optional to avoid that. Moreover, once we get the palantir, which needs to be checked to see if it's null, we need to make sure we don't put a null palantir into the map. But even more importantly, we shouldn't be using put here. If you're going to be using a stream, instead you can have a map call up here. And in the map call, you can do some magic with the get value and set value in order to be able to do the set up here in map, which is a much cleaner way to do it. Let's take a look at another implementation of acquire. In this case, notice this code is calling acquire uninterruptibly. That is not correct. Please read the spec carefully. This is a lock that's acquired and never released. Obviously going to lead to all kinds of problems. These things, again, should be checked by the unit tests, so you're not running unit tests. If you're turning in code like this, it's clear that you're not running the unit tests. So you're just wasting your time and my time. So make sure you run the unit tests. This particular example is also not checking if the Palantir equals null before it's returned. That violates the semantics of this particular method, so don't do that. Here's an example of release on the Palantir manager that's incorrect. You need to check if the Palantir is null before you proceed. This code down here doesn't have any locks, so of course it's going to be full of race conditions. We're checking values that are not protected by locks. For some reason, the lock is being unlocked here, but it was never locked in the first place, so that's crazy. And you also don't need to call get here before you call release. So you should have already gotten this check up here earlier, so by the time you get down here, everything should be copacetic if you've done your code correctly. Okay, so those are my comments on assignment 2B submissions. Please make sure that you address them and run the unit tests carefully and get everything pushed by the deadline, which is available on the website.